Alright, today we're going to review finding the solutions of a quadratic equation. Here's a little summary here that just has that we can factor. And we have 4 different types here outlined with their conditions that we've gone over pretty extensively. And then we also have the quadratic formula. That one always works under all conditions as long as you have your equation equal to 0 and it's of course quadratic, has an x squared in there. And then we do have the square root property where if it has 2 terms and it's in this particular form, you could do the square root property. Okay, so I would suggest that you would pause here and to write this down. Okay, and we're going to do some examples with all of these today or tonight, and make sure that you write down any questions that you may have over in the margin, and you may want to include that on your Google document, Google form. Alright, so here's some examples. We're going to find the solution. So here we have 3 terms, and a is 1. So we are going to do the diamond. This is a diamond problem. Meets that condition. So we want to think what would multiply to negative 14 and add to negative 5. Okay, so 1 times 14 now. 2 and 7 looks like would work. And that would make the 7 negative. So it would negative 7 plus 2, negative 5, negative 2 times 2, negative 14. So we would have 0 equals x minus 7, x plus 2. We're going to find these solutions. So we take each factor and set it to 0 and solve each one individually. So it would add 7, both sides of the equal sign. That's 7. So here's our x-intercept at 7, and then if I subtract 2 on this side, there's our x-intercepts at 7 and negative 2. Remember real quick that a is positive, so we have a parabola that's going to be a happy face. We have a y-intercept of negative 14. Alright, the second example, we have 2 terms. Okay, so we can either if we look at each term, they are both perfect square roots. So this is and it has a subtraction symbol, so we have a difference of 2 squares here. So we can factor this or we can use the square root property. For the sake of this particular example, I'm just going to go ahead and factor this. You could use the square root property by adding 4 to both sides and then square rooting, whichever you would prefer. So if I do this factoring, I want to think about what would multiply to negative 4 and add up to be 0. This is my C and this is my B. There's not a B here. There's no something x. So we would have 2 times a negative 2. Take each factor, set it to 0. Subtract 2 from both sides. My x-intercept is at negative 2, or my solution. Add 2 over here. 2 and negative 2 are my x-intercepts, my solutions, my real solutions. Alright, let's take a look at this one. I forgot to write that f of x. I'm just going to pretend like that had f of x written there. Alright, this one has 3 terms, and a is not 1. So this is a rainbow type problem if we're going to factor. You could also remember, you can do the quadratic formula on any of these at any point in time if you would prefer. Alright, so rainbow, we're going to multiply a times c. So that would give me 30. So what multiplies to 30 and add to be negative 11? So 1 times 30, no, 2 times 15. Can I get an 11 out of that? No. How about 6 times 5? Yeah, if I make both of these negative, negative 6 times negative 5, positive 30. Negative 6 plus negative 5 would add to give me negative 11. So our factors Okay, now because this is a rainbow problem, we have to divide by A. That is the part that we are still having a little bit of trouble with. Divide by A right here. And write it down. We only have to do that, right? Okay, so now we're going to reduce our fractions. So 6 divided by 2, so that gives us 3. This one does not reduce, so I'm just going to write that one down. Now I'm going to kick this 2 out front of this x. Those are my factors. Now to get my x-intercepts, take each factor set to 0. And solve them individually. So I'm going to add 3 to both sides. So there's one x-intercept there, one solution. And then down here, if I add 5, and then divide it by 2 to both sides, there's my other x-intercept. Notice, if you look right here at this line, x minus 3. My intercept is x equals 3. And then if you look at this factor right here, x minus 5 halves, my intercept, my x-intercept is x equals positive 5 halves. So you should be able to see a relationship right there. All right, example 4. I have 2 terms here, and a is not 1. And as I look at these 2 terms, they have a GCF. So I have to think, what could both terms be divisible by? I'm not going to actually divide it. I'm going to bring that number out. So 6 and 9, I could bring out maybe a 3, both divisible by 3. And x squared and x, I can bring out an x. Now I got to think what would go inside the parentheses, undistribute. So 3x times what gives you 6x squared? Well, 2x. And then 3x times what gives you a 9x? 3. And you want to double check that. 3x times 2x, 6x squared. 3x times 3, 9x. Take each factor, set it to 0. Solve individually. So we get 0. Then over here, if I subtract 3 from both sides of the equal sign, divide by 2. There are my x-intercepts. Now, again, you can use your technology to help you check these answers. If you go to your calculator and you go to the y equals screen and you type in your equation and then you hit graph, you may have to hit zoom 6 if your window is messed up. You can see, or at least estimate, where those x-intercepts are. So if I know that, for instance, that for this one, it's x equals 0. As I'm looking at my graph on my calculator, I would hit trace, and then I would type in 0, enter. And if I get 0, 0, I know I did it correctly. And then here I would type in trace, -3 divided by 2, enter, and if the y coordinate is 0, I know that I did this correctly. That's an x-intercept. Okay, let's take a look at this one. We could factor this. I'm going to use you could factor this using a GCF, but since I wanted to give an example for all of them, I'm going to go ahead and do the square root property here to show you how that one works, to remind you. So here, what we're going to do is, because it only has 2 terms, and you will notice that this does not have an x with it. It is in that form y equals ax squared plus c. I'm going to do the square root property. So I'm going to subtract 12 from both sides, pretend like this is a 0. So I have -12 equals 3x squared. Divide both sides by 3. Both sides of the equal sign. And then I'm going to square root both sides. Now, remember, if I physically have to take the square root, I'm going to get a plus or a minus because I have to get two answers because of this fundamental theorem of algebra. If I look at my exponent, the highest exponent on x is 2. I must get two answers no matter what. So the square root of -4, what's the square root of a negative? I hope you know what that means, right? Write it down on your paper right now. It has an I in there. Square root of a -1 is equal to I. Cannot forget that. And if I physically have to take the square root of both sides, I get a positive 2i and a negative 2i. I have to get, if I get imaginary numbers, they must come in conjugate pairs. Conjugate pairs. Okay, now we have the discriminant summary that you can look at here. I would encourage you to pause here and then write this down. And I'm going to go ahead and we're going to do example number 6. To find the solutions, this is A, this is B, and this is C. So to do my discriminant, -3 squared minus 4 times 2 times 7. Okay, here's our discriminant. We get a -47. And so that means that it's going to be two imaginary roots, 0, x-intercepts, no real solutions. All right, so here we go. Quadratic formula, x equals the opposite of b plus or minus the square root b squared minus 4ac all over 2a. So x would equal 3 plus or minus, I just did this part, over 2 times a, and a was 2. So 3 plus or minus 47. We want to break down, if we can, we have a negative, so we know we're going to have an I. Let's see, 47. I think that might be prime, actually. Let's see if we do a 3. Yeah, that's not going to go. A 9. I could do a 5. That could be 45. No, that's not going to go. So it's going to be 3 plus or minus I square root of 47 over 4. And if I could Mickey Mouse reduce, I want to check that. This one doesn't, but you want to check, this is like a 1 there. Check these numbers. Looks like a Mickey Mouse ears. 3, 1, and 4 are not divisible by anything, so we can stop here. If it was divisible here, then I would go ahead and divide all 3 of those numbers, as long as I could divide by the same number for each one of them. All right, don't forget about your Google form, and make sure that if you have any questions, that you've written those down in the margin, and because on the Google form I will ask you to at least include at least one of your questions that you had. All right, see you tomorrow in class, and you're going to be doing some marker sheets, secret markers, over all these types of methods for finding the solution.